Children, today we're going to start with similarity. The first property of similarity is ratio of areas of two triangles. Ratio of areas of two triangles. If you see properly, we have two triangles ABC and triangle PQR. Triangle ABC has base BC and height AD, whereas triangle PQR has base QR and height PS. So we'll term the first height as H1 and the second one as H2. Okay. Now let's find out the area of first triangle ABC. Area of triangle ABC is equal to half into base BC into height AD. Whereas the area of second triangle, area of triangle PQR will be equal to half into base QR into height PS. Both these statements I am getting from definition of areas of triangles. Is it? Now point number 3, we'll try to divide LHS by LHS. So area of triangle ABC upon area of triangle PQR will be equal to, I divided LHS by LHS, now I am dividing RHS by RHS. So it's going to be half BC into AD upon half into QR into PS. Is it correct? This I am getting from statement number 1 and 2. I divided equation 1 by equation 2. In this, we can easily cancel half and half. So what is left out is the remaining part, point number 4. Area of triangle ABC upon area of triangle PQR is equal to BC upon QR into AD upon PS. Now, if you notice it properly, it is a ratio of areas of two triangles. Is it? Ratio of area of triangle ABC to that of ratio of area of triangle PQR is equal to base upon base multiplied by height upon height. So BC is nothing but base of first triangle and QR is base of second triangle multiplied by height, that is height of first triangle upon height of second triangle. So in the form of a statement we can write it as, hence the ratio of areas of two triangles are proportional to the product of the ratio of corresponding base and height. It is ratio, see, just see here, ratio of area of triangle ABC upon PQR is equal to BC upon QR, means ratio of bases, corresponding bases, and AD upon PS is ratio of corresponding height, and it's a product of it. So just can you make it out, the statement, the ratio of areas of two triangles are proportional to the product of the ratio of corresponding base and height. Based on the properties of areas of two triangles, let's see the first condition. If the heights of both the triangles are equal, that means we have triangle ABC and triangle PQR. What I just want to mean is that suppose both the triangles are having equal heights. Suppose this is 6 centimeters. Even the height of the second triangle is also 6 centimeters. Whereas the bases are not equal. So what will happen under this condition? As per the first property, the main important property, ratios of areas of the two triangle, we get area of triangle ABC upon area of triangle PQR is equal to base BC upon QR multiply by height AD upon PS. Now this is because of ratio of areas of two triangles. Whereas we have considered that both the triangles are having equal heights, because both of them are having height 6 centimeter. In that case, we can easily cancel AD and PS. Okay, so what do I get is, therefore, second point, area of triangle ABC upon area of triangle PQR is equal to BC upon QR, because AD and PS has got cancelled. So I get BC upon QR. This is nothing but base 1 upon base 2. Base of first triangle upon base of second triangle. So how do you read out this particular statement? This particular statement can be read as the ratio of areas of the two triangles with equal heights. With equal heights. The ratio of areas of two triangles with equal height is equal to the ratio of their corresponding bases. That means if the triangles have equal heights, then the ratio of areas of the two triangles will be equal to the ratio of their corresponding bases, because your heights get cancelled here. Can you make it out? The height is getting cancelled because they have got equal value, because their heights are equal, therefore heights will get cancelled. So what is left out is base upon base. So how we read out, ratio of areas of the two triangles will be equal to the ratio of corresponding bases if they have equal heights. Now in the same manner, it might happen that both the triangles are having same bases. Both the triangles have got the bases equal. If the bases of both the triangles are equal, what will happen? We have triangle CAB with base AB, is it right? The big triangle CAB with base AB, and a small triangle PAB with base AB again. So can I tell triangle CAB and triangle PAB are sitting on the same base AB, whereas they have got two different heights, that is height CD H1 and height PQ H2. Here the heights are not equal, but only thing is the bases are equal. According to property of ratio of areas of triangle, we can write area of triangle ABC upon area of triangle APB is equal to base upon base AB upon AB into H1 upon H2. In this case, we can't cut H1 and H2 because they are not equal, whereas I can easily cut AB and AB. So what I get is area of triangle ABC upon area of triangle APB is equal to H1 upon H2. That is, we write a statement, the ratio of areas of the two triangles with equal bases is equal to the ratio of their corresponding heights. I repeat once again, the ratio of areas of two triangles with equal bases is equal to the ratio of their corresponding heights. So children, if suppose the two triangles have got same bases, different heights, we can write area of first triangle upon area of second triangle is equal to base upon base into height upon height, where the base get cancelled, and the final result is h1 upon h2, means the ratio of areas of the two triangle is equal to the ratio of corresponding heights. Now let us see, if suppose both the triangles have got equal bases and equal heights. Both the triangles have got equal bases and equal heights. See, we got a red triangle here. I'll name it A, B, C. And the second blue triangle is triangle PBC. Both these triangles stand between the same two parallel lines, that is L1 and L2. L1 and L2 are the parallel lines. So you might be knowing, if suppose the triangles are standing between the two parallel lines, the gap, the distance between both the parallel lines are going to be equal. For red triangle ABC, if I assume AD is a height, AD is a height, and for this obtuse triangle PBC, if I assume PS is the height. So here my height, first triangle's height is AD, second triangle's height is PS. If I apply property of areas of the two triangles, what should I get? Can we write it like this? First, area of triangle ABC upon area of triangle PBC is equal to base upon base, that is BC upon BC. You can see both the triangles are sitting on the same base BC. Okay, multiply by height. First triangle's height is AD and second triangle's height is PS. This I got from ratio of areas of two triangles. Okay, now let's see, can it get cancelled? See, both the triangles are sitting on the same base, so I can easily cancel BC and BC. Same is the case, even AD and PS are equal. Why AD and PS are equal? What is the reason why AD and PS will be equal? It's because this is a distance between the two parallel lines. So I can even cut AD and PS. So what is left out? I'll be left out with area of triangle ABC upon area of triangle PBC is equal to 1 upon 1. So can I tell the ratio is 1:1? The ratio of areas of the triangle here will be 1:1. But under what condition? The condition is that if the triangles have equal bases and equal heights, the ratio of areas of the two triangles will be equal to 1:1. Whereas suppose if I'm not writing in the form of 1:1, if I cross multiply, if I try to cross multiply, what do I get? Can I write it up like this? If I cross multiply, it will be area of triangle ABC is equal to area of triangle PBC. Is it, if I cross multiply? So what does it mean? The condition tells if the triangles have equal bases and equal heights, the ratio of areas of the two triangles will be 1:1. So see what he has mentioned the statement. If the triangles have equal bases and equal height, then the ratio of areas of the two triangles will be equal to 1:1. Now, based on the properties what has been taught to you, let us see some conditions, some different types of sums what can come up. Suppose if they ask us to find out area of triangle APB, area of triangle APQ, area of triangle APQ upon area of triangle BPQ. Just see triangle APQ. and triangle BPQ. Can I consider for triangle APQ base as AP? Because QT is the height. Since QT is the height, AP can become the base. Is it right? Whereas for triangle BPQ, here I am considering PB as base. And it's an obtuse triangle. Since it's an obtuse triangle, the height will go out of the triangle, it will be outside. And again, the height is going to be QT. In these two examples of the triangles, you'll see that triangle APQ and triangle BPQ have same height. They have different bases, but they have the same height. So if I write according to property 1, area of triangle APQ upon area of triangle BPQ, what should I get? It should be base upon base, that is AP upon PB, multiply by first triangle APQ, height is QT, upon for second triangle, obtuse triangle PBQ, height is again same, what is that? QT. This is my property 1. Based on this, if I try to cancel, since they have different bases but equal heights, can I cancel this QT and QT? So what I am left out with is therefore area of triangle APQ upon area of triangle BPQ is equal to AP upon PB. That means if the triangles have same height, the ratios of areas of the two triangles will be proportional to the corresponding ratio of the corresponding bases. This was one way the figure has been drawn. Let us see exactly the reflection of it. See, in this particular part, we have again two triangles APQ and triangle PQC. So if I put it up, area of triangle APQ upon area of triangle PQC. Now for triangle APQ, can I take basis AQ? And obtuse triangle PQC, the base part is QC. For first triangle APQ, from point vertex P, we have drawn a perpendicular. PT is the height. Again, for obtuse triangle PQC, we have got the same height, which is that thing PT. So if I apply the property here, area of triangle APQ upon area of triangle PQC, I get base upon base AQ upon QC into height upon height, that is PT upon PT. This is ratio of areas of two triangles. In this case, again, both the triangles have got the same height, so we can cut PT and PT. So what are we left with is again, therefore area of triangle APQ upon area of triangle PQC is nothing but base upon base, that is AQ upon QC. Okay, so we just saw different types in which they can apply ratios of areas of the two triangles. Now see the third possibility, how it works out to be. Here we got two triangles. In this case, I'll consider PQ as a base. If we consider PQ as a base, we have two triangles between two parallel lines L1 and L2. L1 and L2 are the two parallel lines. If suppose these are the two parallel lines, the distance between the parallel lines are going to be always equal. So can I tell that BX is equal to CY? So we have got one obtuse triangle BPQ. So how will I put area of triangle BPQ upon the second blue obtuse triangle? Can you see CPQ upon area of triangle CPQ? Children, both these triangles stand on the same base PQ. So what should I get? Base upon base. It should be PQ upon PQ. Multiply by height upon height. For the red triangle, height is BX. And for the blue triangle CPQ, the height one is CY. It is CY. Reason for this will be ratio of areas of two triangles. But children, just see, your bases are equal, even the heights are equal. But why the heights are equal? Because that's the distance between the two parallel lines. So in this case, we can cancel PQ and PQ, even BX and CY. So what I'm left is 1 upon 1. Reason we can tell triangles with same base and equal heights. So I get ratio 1:1. If I try to cross multiply, that is area of triangle BPQ upon area of triangle CPQ is equal to 1:1. If I cross multiply it, what do I get? Therefore, area of triangle BPQ is equal to area of triangle CPQ. So this is how we come to know various application of property of areas of two triangles.